Okay, so number 23 says that you've got a car moving south at a car moving south at 1383, and it's moving south at 11.2 meters per second. It's struck by a bigger car. Moving east at 31.3. Okay, so I got a bigger one, a bigger, faster moving, hitting this one, and they stick together. I bet that they're going to be going this way more than they're going. Oops, sorry. That's not the right. They're going to be going south and to the east, like that. So what I'm going to do is first find the x piece to this and the y component, because momentum is going to be conserved, assuming I don't lose anything or there's no outside forces. So first I'm going to break this into the x direction and the y direction, and in both cases the momentum before is going to equal the momentum after. So before, in the x direction, this is the only one that's moving in the x direction, so its mass 1732 times the velocity 31.3. This is not moving left or right, it's only moving up and down. And then after, since they stick together, their mass, you have to add them up, and I'm going to need a calculator. So 1732 plus 1383, 3115 times its velocity in the x direction. So the velocity in the x is going to be 1732 times 31.3 divided by 3115 is 17.4. So my velocity in the x is 17.4. Now I'll do everything in the y direction. So things that are moving in the y is this car, 1383 times velocity 11.2, and this is not moving in the y, is equal to the mass 3115 times the velocity in the y. Since they stick together, I just use the same mass. So the velocity in the y direction is 4.97. So now I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared. So 17.4 squared plus 4.97 squared, square root 18.1. And then to find the angle, because I think it asks me for the angle, how fast and in what direction. So this angle, I'm going to use the inverse tangent of 4.97 divided by 17.4. And so always make sure your calculator's in degree mode. So inverse tangent of 4.97 divided by 17.4 is 15.9 degrees. So 15.9 degrees south of east.